Okay, so let's do a 1-minute intro about like who you are. Don't have to do anything specific, and then we can get started.
I'll go first. Hi, I'm
Yeah.
Nikhil, and I have been a software engineer for 9 years. I have a master's degree in computer science,
Mhm.
and I'm looking for opportunities in AI/ML space.
Okay, cool. Yeah, so I'm Anatoly, and I've been a full stack engineer for about 3 years. And right now I'm working in like infrastructure. So
Mhm.
I was doing product focused infrastructure. Now I'm doing or product focused full stack. Now I'm doing infrastructure.
Oh,
So also looking to like learn some AI. So I've been doing some of that, doing some projects and stuff. Okay,
nice.
so let me paste the first problem,
Sure,
and you can let me know if you have any questions.
sure.
So yeah, we'll do two problems. By the way, I think I said this,
Mhm.
but yeah. And I'll paste an example as well.
Okay. So, number of possible unique paths that the robot can take to reach the bottom right
Mm-hmm.
corner. Okay. Mm, mm. I'm thinking of this as a TP problem.
Okay.
Uh, so let's say I have a 3 into 3. I wish I could draw something.
So there
Uh,
is a drawing mode.
yes,
Yeah, I
right.
can. That's fine.
So let's just take this. Okay, okay. I think I have it. One see. Oh, delete.
Do you want to make a matrix, like a 3 by 3
Yes,
matrix?
yes,
Let me just make it for you real quick.
yes.
So here's
Okay.
that, and then I'll just make it. So
Mhm.
here you go.
Oh, that's easy enough.
Yeah. Okay.
So we have to get here,
Mm-hmm.
and let's say our uh, obstacle is here,
Mm-hmm.
and the problem is saying what are the number of unique number of paths, basically, right?
Mm-hmm.
From, and we always start from here,
Yeah.
right? So from here we start, and we have to get here. So if we go through this example, uh, we can come and we there are restrictions on the movement, right? So there is no movement like this, just
Mm-hmm.
down and right.
Yeah.
That's, yeah, down and right. So it can go here, uh, and it can come here as well, but there is an obstruction, so it can't. So it can come here, it can come here. So one path is this one,
Mm-hmm.
uh, basically this one, and another path is, it could have gone this one, but due to obstruction, it can only come. So there are like two ways for this.
Mm-hmm.
I think this is the solution. One one denotes the obstacle, right?
Mm-hmm.
So okay. Uh, so let's do. I'm going to try and do it in a top-down manner first.
Sure.
Mm, so,
So before you like code, can you explain kind of like your thought process of what you'll be doing?
uh, okay. I hope the drawing has not gone away. Um,
I think it stays.
yeah. So what I'm thinking is, uh, I'm so let's like just look at it as a recursive problem,
Hmm.
or a depth first search problem would be like a better way to like exploring options, right? So if it is here, it can go in this direction
Hmm.
or this direction. And the success criteria, the base case is getting here. That should count as one path, right? One.
Hmm.
And if you hit some obstacle in between, you should return from there.
Hmm.
So at the end, I have to like just count the ways of getting from this place to this place in a and returning that.
Okay. And then so basically from every place you will count like, so let's say you start here, like what would be your recursive case?
So so I can go here one step,
Hmm.
and I can go one step here,
Hmm.
and then again I can from this place I can go here, or I
Hmm.
can go here, but like this is not allowed, so it will return zero.
Okay.
uh, it will just return.
Okay. So basically, if you hit the obstacle, you'll return 0 or something. And
Right.
then if you hit a successful path, you'll return
Mhm.
1 and you'll just like add those up.
Yes, that is what I'm thinking. uh
Okay.
I It's not still clear to me at code level, but I'm trying to think it through.
Sure.
uh so like if it's just even backtracking, I'm thinking maybe will it be easier to like uh, assume that we are here and backtrack to this, that in how many ways we can reach 0, 0, but the problem stays the same. So
Yeah. I
I
mean, you just go the other way. That doesn't really
yeah,
matter.
so that is not an issue. Uh, if the idea made sense, do you think I can start coding?
Yeah, I think it's good. If you want to write any notes, you can. If you are pretty good, then you can code. Totally fine. I think I get what you're trying to do.
Okay, so we have our obstacle grid. I'm going to just take the rows. Uh, is len.
Oh, and so one last thing before you start coding. So, what would be the time and space complexity of your solution?
Uh, so time complexity would be O into O of m into n, like number of rows into
Okay, yeah.
columns, and space should be a grid of OMN if when we like are storing the values
Hmm.
for each row and column to like uh, the DP array, basically the DP table.
Yep, got it. Okay, so MN and MN. Yeah, it sounds good.
Yeah.
Okay, you keep going.
So I'm doing zero. I'm saying um, we can do a simple uh, edge case check that if obstacle grid 0, 0 itself is 1, we can simply return 0, right? Uh,
Yeah, it makes sense.
uh, okay. Now I want to write a backtracking function.
Okay.
Uh, that's not, what should I? What would be a good name for the function? Um, okay, track, and I'm saying I'm passing in the row and the column,
Hmm.
and then I'm saying if row obstacle grid. What are my base cases? If okay, we can do a edge case uh, edge case check, like boundary check. If R is less than 0, or C is less than 0, or mm, R is greater than equal to rows, and C is greater than equal to rows,
Mhm.
not and, or this thing is uh, is an obstacle. We can return 0.
All right.
Uh, else we can return else we can do we can move down. Mm, I'm thinking, so I need to maintain state, right? So
Mhm.
for maintaining a state, I'm thinking of putting in a path variable which will have the list of the state path it has gone through.
Okay.
Does that make sense?
So yeah. So what are you gonna use the path for?
Of like the way it's like moving across the matrix, right? So I'm just like going to add like the row and the column it has been through.
I see. So you're saying like, if I start at 0, 0 and go to 0, 1 and 0, 2, you'll have that full path. So it'll say like 0, 0, 0, 1, 0, 2. So
Right.
whenever it occurs, I'll have the full path.
Yeah,
Okay.
something like that.
Sure.
It's not very efficient though. I'm thinking how I can.
Hmm. Well, you also mentioned like your time complexity in space when I asked you. You said it was mn, right? So if you store the path, it'll be bigger.
Yes, it will be bigger. That's why I was hesitating to like think of that.
Hmm.
Uh okay, so we can do a backtrack R plus 1, comma C,
Hmm.
and backtrack R comma, so R plus 1 is down,
Hmm.
and I want to go right, so R comma C plus 1.
Hmm.
Uh, and one case I missed here was if obstacle grid um, R C equal to mm, it doesn't matter what it is, it will reach there, right? Like it can go there even if the last cell is an obstacle, it doesn't matter. So R equal to rows minus 1 and C equal to col -1, and it has to be it can't include, so let's see.
Okay.
Uh, Now, um, trying to see. So I can go return, backtrack, 0, 0. Mm, don't think I'm doing it correctly. Uh, so the rows is obstacle create column. If the row is okay, the boundary check is fine. Uh, this is fine. So, I'm going to use a cache to
Mm-hmm.
store the values. Um, so the check, I can do the first check itself. If r comma c in cache return
Mm-hmm.
cache r comma c as the tuple, and I think there is some logical issue. I'm not thinking clearly. Um, do you want to move to another problem, or like?
No. So I'll ask you, right? So you have most of it. So you did these two backtracks, but you
Yeah,
didn't do anything with the results, right? So on line number
right.
40 and 41, so you have
Mm.
this cache, and if something's in the cache, you return
Mm.
it. But you never store anything in the cache, and you never do anything with these results. So what do you think you should do?
So
Like you're never gonna get a hash. You're never gonna get a cache hit because you're never storing
right,
anything.
right. So I think I am having difficulty. Let's say I have a variable here,
Mm-hmm.
res equal to 0. So res plus equal to this,
Mm-hmm.
and res plus equal to this.
Mm-hmm.
I think the problem is like thinking in terms of the scope of how the variables are passing through, and I am going to like do this
Mm-hmm.
equal to res, and here I'm going to return res,
Okay.
uh, and then we can simply call backtrack 00
Mm-hmm.
and uh, return cache 0, 0.
Mm-hmm.
What I'm not sure about is I feel like I'm like vibe coded it a little bit and like not at least it's not very clear in my head even if the code works.
Mm-hmm. Okay.
So
Yeah.
um, we are good till here.
Mm-hmm.
I created a cache for like storing the intermediate results.
Mm-hmm.
I said row and column in cache is like if it's there, just return it.
Mm-hmm.
I'm going and saying invalidating these things that okay, if you're like out of bounds, please just return 0.
Mm-hmm.
I am not very sure that 0 is the way to go. So
So what could be a problem with zero? Like, why do you think it's not?
uh, like it should be something which is like okay, I okay, that could be fine. So any in out of bounds is 0 and any obstacle is 0.
Mm-hmm.
So hmm, and then I'm saying okay, so I have reached to return 1
Mm-hmm.
and again I'm getting a little confused with my own flow of so this bit is fine. I have having difficulty like having the order of these things properly.
Right.
When-
So like, so basically, like, if you already computed it, you can just return right away. That makes sense, right? If
Mhm.
you're out of bounds,
Mhm.
then it's zero. That makes sense too, because it's like a dead end and it's not a
Right,
valid path.
right,
And then you can go in two directions. You can either go right or down. So you can just like
right,
add up both of those.
right.
And then once you get your result, then you're storing it in the cache. So that way, if you get here again, then you'll have a cache hit, and then you return. So yeah, it makes sense to me. Um,
Do you want to me to run this and see?
no, I'm pretty confident this will work. Besides, yeah, we can't run your code, remember? So
Okay. Oh,
yeah.
but I still have like some conceptual. I'll go back in
Hmm.
after
Yeah,
this.
you can definitely go back and clarify. Yeah, for sure.
Okay, okay,
And I guess we don't really have. So DP is kind of annoying to do a dry run. I'm pretty happy with this, though, so let's just move on to the
okay,
next.
okay, okay.
Okay. So the next problem is this. I'll just paste it. And I'll give you an example.
And nodes represented by edge rest or edge. Start to end and return its success probability. Start to end return 0. Your answer will be accepted if it differs from. Okay.
Yeah, I guess you don't have to worry about that. Your answer will be accepted because I just copied it from LeetCode. So
Oh, I've never seen this problem, so
okay.
give me a second, please. You are given an undirected. Okay. Okay. Connecting the nodes A and B with the probability of success of traversing that edge. Success probability I. Start and end. Find the path with the maximum probability of success to go from start to end and return its success probability. Okay, so n equal to 3, edges are 0, 1, 1, 2, 0, 2.
And you can draw it in the drawing if you want to, if that makes it easier.
Uh, let's draw something new. Uh,
Here, I can just delete that for you.
uh, so we have 0, we have 1. Uh, like 0 is amazing. 0, 1, 2.
Hmm.
And so edges are 0 to 1 and 0 to 2
Hmm.
and 1 to 2. Since it's an undirected graph, so that doesn't matter. Like,
Yeah.
I guess you
Yeah, it's
can go from
undirected. So, yeah.
right. So success probability is what? There are two paths from start to end. One having a probability of success 0.2 has 0.5. I think not with the probability of success that edge. So connecting 0 and 1
Hmm.
and the probability is uh, 0.5. I
Hmm.
would same with 1 to 0.5,
Hmm.
and this is 0 to 2 is 0.2.
Yeah, so this is 0.5.
Right. So give you are given start to end
Hmm.
path with the maximum probability of success
Yeah.
and return success probability. So from here 0 to 2 we can go 0.2 is one probability. Another probability is going to 0 to 1 and 1 to 2. So here our probability 0.5 and then it gets multiplied with this, that is 0.25.
Hmm.
So I guess that is what it wants us to return.
Hmm.
Okay, how do you, I'm thinking of algorithms to put through, like
Hmm.
they're like to get to 2 from 0, they're like, and it's just a simple graph, right? Like, but like there are like so many edges it could have, and there are
Yeah.
like so many paths, and so each has a weight associated with it, right? Each
Hmm.
edge has a weight associated with it. It's like that's the success probability I'm thinking. uh, and all of these weights are like positive. Is there, is it somewhat related to like Dijkstra's algorithm?
Okay, and how would you do that? How would that help you?
uh hmm, okay, I am like blanking on that one. uh you have to take uh you do for that vertex and edge, and you keep on removing. It's, is that a weighted thing? It's like a greedy algorithm applied on a graph, if I remember correctly. uh,
Oh,
so
so are you asking, like, do you remember what Dexter's is, or like,
yeah, I'm trying to remember
I
what
see.
that is. So I'm wondering if we take the greedy algorithm,
Hmm.
and we know that uh, we have choices from 0 to 2, right? Like, so either
Hmm.
we can go straight away, so that is 0.2, but then there is another path that is 0.5, so we can pick that path,
Hmm.
and then we reach 1, and then we can get to 2,
Hmm.
uh, and then in we are also computing those, and at then we have this 0.25, which is the best probability. I am
Hmm.
not very sure how to implement that. I can. Mm, but is Dijkstra's algorithm
Yeah,
correct?
so you can basically, so I can give you a little bit of like
Yes.
help. So
Yes.
basically, with Dijkstra's, you start out wherever, and you
Mhm.
put in like all your edges with like weights into a heap, and then you just always
Yes,
take
I
the
need
shortest.
the
But in
moment.
this case, it's probability, so you're gonna have to modify it for probability. So hopefully that helps.
Uh, okay, so let's say uh, I have a heap, right? And I'm going through this edge list. I'm putting everything in the heap.
Hmm.
Uh, so I'm starting out. So it will pop out these probabilities. We want to pick. mm, Will it be helpful to like have a tuple of this, or like when we are feeding it to the heap,
Yeah, so you have a heap, right? So
right?
there's a couple things you need to know like for your heap.
Mm.
Like so let's say this wasn't probabilities. Let's say this was like shortest path, right?
Yes,
So you
yes.
would typically store like the length of your path
Mm.
and then what node you're on. And then
Right,
you would always just pop off the shortest like the smallest.
right,
And then whenever you see like should I visit this place, you see like have I already been here with a smaller path? And if I have, then like why would I go here again? So with a probability, now it's kind of like reversed where you want the highest probability. So you got to
right.
store probability and like where you're currently at as your like things. So yeah, you
Mm.
could have a tuple. That makes sense.
So let's name it something. Success probability, and I, I I think algorithmically I understand, but I need to implement it.
Mm-hmm.
If you are okay, I can start with.
Sure.
So we have inputs n, edges, and success prob. Uh, okay. We have these three things.
Uh-huh.
Okay, so let's take a heap.
So you actually have two other things here. So you have a start and an end location.
Oh yeah, yeah,
So start.
yeah. Thank you, thank you.
Mhm.
Uh, so I have these. Hmm, okay, so into uh, I'm getting a heap.
Mhm.
Okay, and for I change len edges.
Mhm.
I'm going to EQ dot heap push heap, and I want the maximum probability at each node, right? So
Yeah. So I'm confused. Why are you pushing every edge into the heap?
uh,
Like, what do you need to do first before you traverse anything? Because like you need to start at the start. So like
right.
the only edges you need to push into the heap are the edges that start at the start. But then you also need to be able to like traverse a graph. So can you traverse a graph by using the edges?
Okay, I think I understand what you're saying. So I already know. where I am and where I have to get to,
Mm-hmm.
right? So oh, mm, okay, I'm going to make a dictionary uh, which will have uh, edges and the weights associated with it, success probability.
Yeah, so you need to make a graph. So,
Right.
like right now you have edges, so you need to make a graph.
Let's see. Make a graph equal to functions of for list uh, for r and edges. Uh, I can do this graph. Uh, and so s comma e equal to graph. Sorry, edges I, and I can have graph s. So append e comma. Will that work? And then we have to do it the other way around as well.
Yeah, I think this works.
Graph e. So now after this we will have the graph.
Mm-hmm.
Now I I can have a heap which will now keep track of uh, the probabilities.
Mm-hmm.
Like we need to have it give us the one with the highest probability, right? At any given point.
Yeah,
How?
so you can use a max heap.
Yes. So I'm thinking how to um create that. So for uh, node node in graph, uh, it's a dictionary, right? So key in value.
Yeah, so
Uh,
why are you trying to go through every node in the graph?
I don't need to go through every graph. So
Yeah, like you always start at the start, and
yes. So,
what's your probability of starting at the start?
uh, is my probability of starting at the start? It's
Yeah.
that's like 100%, isn't it?
Yeah, exactly. Yeah. So you would just store like probability of 1 and then the start node in the heap, and that's it.
So let's say our answer, which will initialize it as like one,
Mhm.
right? So and while uh, I'm having difficulty thinking like
Mhm.
so let's say we are here at zero, right? And we started from here. So how do I do that? Uh,
Yeah, so maybe let me draw another thing for you, and I can explain it with the drawing, and then you can try to code it. So let's say, let me delete this thing again. So let's say we have these three nodes. Let me zoom out as well, so it's easier. We have these three nodes, right? And we
Right.
start at the start.
Mhm.
So basically, the idea of Dijkstras is you have a heap. So I'll just I'll just do like a dry run here with a heap, and then you can do the actual code. So our heap will just have like probability of 1,
Mhm.
and and you have to figure out how to do a max heap. So, but let's say we do pop the max. So we start at node 0.
Mhm.
Then basically, you pop off the heap.
Mhm.
Uh, so pop off the heap.
Mhm.
Check if you are like at where the end. If you're at the end, you can just return. And if
Right.
you're not at the end, then you take all of the edges that our node has. So like let's say we're here. So we pop this node off. We take all of the edges from our node, and then we add those to the heap along with like our new probability. So if this is like zero point 0.5, then we would
Mhm.
add like 0.5, and this would be like the next node we're at. So maybe this is like 1, 2, whatever, something like
Mhm.
this. So we'd say like, okay, so we have a 0.51, add that to the heap, and then this is a 0.22, add that to the heap, 0.22. And then basically you're always popping off the highest probability off the heap.
Mhm.
So then
Mhm.
you're guaranteed to get the highest. And then you also need a visited set to make sure you don't like revisit the same node over and over.
Right.
But that's the basic idea of like
I think so. Basically, it's like BFS with a heat. So
Yeah,
let
it's literally BFS with a heap, and the visit is a little bit trickier than a BFS, but yeah, pretty much.
so I have a visited set, and uh, I am initializing the heap as uh, probability,
Mm-hmm.
comma start node,
Mm-hmm.
and I will keep it as negative
Okay, yeah,
to simulate a max heap.
sure.
That sounds right. While heap, right? So I am saying uh, P for probability and node equal to uh, PQ for heap pop
Mm-hmm.
uh, heap, and then it's negative, so I have to change it to positive. Like if when I'm working with it, I have to change it.
Yeah, that's
So
right.
if node is equal to end, we have our answer.
Mm-hmm.
So we can simply return minus p.
Mm-hmm.
Else, I mean, no else, we need to go and for node for n in our graph, I'm going to go uh, n
Mm-hmm.
and okay, for n in graph n.
You have n twice.
Yes, this is what I want now. But here I think this works. So for node comma uh, probability, right? Uh,
Mm-hmm.
that is what I did here.
Yeah.
So uh, I'm going to if n not in visited, uh, I can add this to the heap q dot heap push heap comma minus p, mm, minus p into probability that we got from this node.
Mm-hmm.
It's a tuple, so I want to I have not made it minus still, so that's like still negative. When I'm pushing a negative value. So I I need to make this also. No, it's fine. Okay. And the node and
Okay.
and uh, visited dot add the node n.
Okay.
Uh, uh, I think we should keep trying. Am I missing something?
I think he said what? We should be fine.
Yeah.
So what should you do if you get to line 90?
Uh, I need to return the probability, but no, that means I couldn't reach the
Mm-hmm.
uh, like if I come out of the loop, I have not been able to visit the end node.
Mm-hmm.
So like, what should we return in that case?
Yeah, so it's 0 in the problem. Okay.
Zero.
Okay, cool. Do you see any issues or does this look good to you?
Uh, Here it's taking. Ing. Not equal to. I think we should be good.
Okay, so I can give you one bug. So on line 89, like this would work for a BFS because BFS is first in, first out. So if you add something to the BFS, then like you can mark it visited because like you know that the next thing gets in
Mhm.
after. In a heap, that's not guaranteed, right? I can put in some number and then I can put in something that's like bigger later, and I should still visit the later thing first. So your visited thing is not correct.
Hmm. So
There's like two ways to do this. One is like better but harder, and one is like easier but a little bit worse. So let's just go with the easier, like the obvious solution, I guess, if you can think of
so
that.
uh, is is that incorrect to add it here?
You can add here, but you have to do something else, which is more complicated. So I would just suggest to add somewhere else that's like more obvious. Like where for sure can you add it, and it wouldn't be a mistake.
Mm, After it has popped, I can.
Yeah, because if you popped it, you know you visited it because you're like
Yes,
on it right now. Yeah. So
visited dot add node.
okay.
So I still want to do the check that it is not in the visited set, right? Right. So I
Yes, you still need to do it. Yes.
if and not in not in.
Yeah, because otherwise, if you had like 100% probability of
Mhm.
going, you would just go back and forth a lot. So
Mhm.
yeah, because it's undirected. Yeah. Okay.
Okay.
Okay. I think we can stop here. I think we're right
Yes,
around 50
yes.
minutes.
I
So
I have not lead coded for like couple of weeks, and it shows.
mhm. Yeah. So how do you think you did? Like, what are the things you think you did well? What are the things you didn't do well?
Uh, there is a tendency to like vibe code. I felt that like I know it, but like getting to the nailing it is a little difficult for me. But I'm
Hmm.
like open to uh, like what should I do to like improve
Right.
like
Okay.
integration.
Okay. Yeah. So I said that um I think you asked me like, is it better to do an interview where you can run your code or not?
Mhm.
I think in your case, it's probably better to practice with running your code because it seems like you know the algorithms, but it's like you read them in a book or something and like haven't coded them in a month, you know? So you're like,
Yeah.
I know this thing exists, I know it's like roughly this, but like what is it exactly? I don't know. Uh, and so I would definitely recommend like doing the problems and running the code and making sure it works
Mhm, mhm,
until you're super comfortable with the algorithm. So I'd say like so feedback for the first one, you didn't really restate the problem and like really go like I would just say like, hey, okay, so I have this like robot that can go like down. Like it wasn't very clear to me that you knew what the problem was
yes.
asking basically.
Yes.
So I would say like, okay, so I start at like 0, 0, maybe I'll draw it and then I can go in these directions and
Mhm,
then I have these obstacles and stuff. The other thing is you didn't ask about edge cases, but your code handled it. So like, what if the start or the end is an obstacle? You didn't
mhm,
ask, but your code handled it. So either one's fine. If you don't ask and then your code handles it, fine. You can ask as well. So
yes.
because I might just say like that can never happen or whatever. So those are the little things that a lot of people don't do is like restate the problem, ask for edge
Mhm,
cases. Well, like what if the matrix is empty? That kind of stuff.
mhm, mhm.
Do I have to worry about that? And usually people will just say like it can't be empty. It can't. It's like it takes like 30 seconds, and you can fail an interview if you are solving the wrong problem, and they
Hmm.
don't tell you you're solving the wrong problem. And I
Yes,
have had this
they give
happen.
you enough rope to hang yourself.
Yeah, they
Yes.
give you enough rope to hang yourself. So it's like 1 or 2 minutes of like making sure you don't fail.
Mhm.
If they're nice, they'll correct you. If they're not, they'll let you code for 30 minutes and then you'll fail. And I've had that happen. I think I've passed like 90% of my like coding rounds, and like the only one I didn't was that. I just like misread some easy problems, like, oh, it was just like this other one I did. Okay, man, why is it so hard? Like, and then I realized like they were asking for something way easier than what I thought, and the guy just like didn't tell me anything for 35 minutes. So yeah,
I
okay.
have like not coded a lot in like last month or so.
Mm-hmm.
Actually, I've been working on my communication.
Mm-hmm.
Like for the soft behavioral parts, I am striking out on those.
Oh,
And
like the behavioral interview.
yes,
I see.
but I am trying to get back into the groove.
Yeah,
The
yeah.
first problem was a scene problem, so I should have done better.
Yeah,
So,
yeah. So I think you said you said you did a lot as well. So I was like, okay, well maybe you don't know DP, but for having done the number of problems you have, I'm assuming you have.
mhm.
And it's a pretty like as straightforward as DP is. I mean,
Yes, yes.
obviously if there was no obstacle it would be easier, but like it was pretty as straightforward as it can
You
be.
know, no, it was a straightforward problem.
Yeah, yeah. So so it was also good that you said DP I'll do top down. I would recommend this.
Mhm.
Bottom up. So think about like how much problems you had doing what's it called? Oh, 1 second. Cat's trying to get out. Okay. So yeah, so basically think about how much problem you had with top down, bottom up. I usually don't recommend people go bottom up, and it's good that you chose top down because top down is easier, and bottom up there's more room for error. In an interview, like
Mhm.
you just want a solution that they're happy with, that you can code fast and you don't have mistakes, and you're not like stuck for 10 minutes thinking like, oh man, like where do I have to go in which direction? Like is
Mhm.
it this or that or so I would definitely recommend top down. If they ask you for bottom up, then do that and like unlucky, but I would definitely recommend that.
I have like sat down and like done like those lists you have, right? Like these are the DP problems to solve, and I have done that,
Uh
and
huh.
um, I think I understand the top down quite well,
Yeah.
and like I even if it's a difficult problem, I can like think my way through to that. But it's like in bottom up, it's like it takes time, and in an
Yeah.
interview scenario, I
Yeah, it takes time and there's way more chance you get bugs. So top down, like I've gotten people that don't know DP to do this kind of problem in like 4 days. It's not super difficult once you like it's like I have a cache, I have a base case, I have a recursive case, that's it. Like I just call them it's like a DFS like you said. Um
Um, one thing I wanted to tell you that maybe if I would have been solving these problems on my own,
uh-huh.
I could have done better. But like with you sitting there and like like that evaluative thing is there, and it's
Uh-huh.
totally on me. I was like uh, always like second guessing myself, and
Hmm. But it's like usually the way I see it is like the interview is worse, right? Because like with
yes,
this
yes,
thing, it's like if you fail, you can just schedule another one. In an interview, if you fail, you have to wait a year.
yes, yes,
So having some pressure is definitely good
yes,
because you need to prepare for like
yes.
yeah, like so you just
Uh,
so that I would just say do enough. Like you can schedule more mocks.
mhm.
Like when I was interviewing this year, I scheduled like 20 mocks. And a lot of the mocks I did for DSA, it was just like, oh yeah, perfect, done. I was like, okay, cool. Like that was most of it.
Okay.
So, but you just need to be comfortable. Like, okay, I'm doing a mock. I'm totally not nervous. You know, like the nerves. If you're super nervous, like I've seen people that were nervous to the point of like they just couldn't focus on anything. And it's like if you're there, like how are
No,
you gonna pass? It's impossible.
I can tell you this, like I've gotten much better, but like 3 4 months back I did an interview and I thought I had like a out of body experience. Like
Yeah,
I was not with
yeah.
myself.
So I had one that was also an extreme case where the person was like almost crying, and I was like, all right, like
Mhm,
I could tell you how to improve your problem solving, but if you're like in this position, like you're just not gonna do well. So you
mhm,
need to like be calm down and stuff.
mhm, mhm.
Yeah. So that's just like, schedule more, and
Okay.
as you do more, you'll be more comfortable and stuff.
Uh,
Um, oh yeah, go ahead.
oh, I told you right. Like I wanted to talk to you 10 minutes on something
Yeah,
else.
let me
Apart
just finish this thing,
yes.
and then I can do that. Yeah.
Yeah.
So basically I would because like you said this is straightforward DP, like
Mhm.
realistically you should be able to code this in like 5 minutes. Like so
Yes.
like I make a
Yes.
cache, I have a base case, whatever.
Mhm, mhm.
And you spent 20 or so. So you
Yes.
came up with a solution really quickly. So it's like your algorithm knowledge is like pretty good. But then your coding was like really slow. So that's what I would work on. Like if you think you can get like, you said you're like vibe coding.
Mhm,
So really work on like, okay, I have an algorithm. Like honestly, maybe here, like redo this problem like 5 times and make sure you can code it in like 5 minutes every time. And like you're super comfortable with like, okay, this is how I code a DP thing. Because basically there's like multiple parts. So there's like, can I go from a problem to a algorithm, which it seems like you were doing pretty well, and then
mhm.
how can I code that algorithm? Can I code it quickly? Can I code it without mistakes? And like that you could speed up like significantly, and that's going to be most of your growth. I feel like it's just like
Okay.
coding more, and then not also realistically nowadays, because so many people are like cheating. If
Mhm,
you're coding and you're like, I'm not sure, I don't know, like I could have totally been like, are you just like like using whatever something and like copying the solution? You have no idea what the hell you're doing, you
mhm.
know? So like that isn't going to be great for a for like an interview setting. Like you never want people to think you're like cheating if you're like, writing stuff down and you can't really explain anything. Uh,
Oh, wow. Okay, I hadn't thought about that. I know that people are cheating.
Yeah, exactly. So you really want to make sure like that you know what you're doing because then people don't even have to like think about it. And I guess people are like paranoid or something. I don't know.
Mhm, mhm.
But so that's another thing. And then yeah. So for the second one, so you came up with Dijkstra's. I mean, I guess you've like heard of it. You've probably done it a few times, right? If you
I
came up
have
with it.
done it a few times, like not
Okay.
a lot.
Right. And so that's another one that was kind of a similar thing where it's like you knew it was Dijkstra's, but you didn't know exactly how it works and what the code looks like and all that stuff. So I would
Mhm.
just code out like Dijkstra's like 10 times until
Okay.
you're like super comfortable. This is exactly how it works.
Yeah.
Because in a real interview, I can't be like, okay, well, this is how Dijkstra's works. Let me draw you a picture and like all the steps.
Mhm,
And, it's like you know it or you don't. Um, so definitely like familiarity with how to code the algorithm is like
mhm.
very important.
Is
Yeah.
Dijkstra's coming up a lot these days?
I don't think so.
Mhm.
But
But
I asked you this stuff just because you did more problems, but it's not like it's
yes, yes.
hard.
I had a a year back. I had topological sorting come up
Uh-huh.
uh, in a different form. It was like a non-lead code problem, but it was topological sorting.
Hmm.
Uh, and I had not like practiced, but like I like talked through the logic and like just came up with with the solution during the interview.
Hmm.
But like these like visited things. I did like multiple times, like redundant code was there in there. So
Yeah.
you are right.
So you could have probably, if I let you run your code, figure out like, oh, I'm visiting incorrectly, and you were like pretty close.
Mhm,
But yeah, topological sort also, I did have it come up during an actual interview,
mhm, mhm,
as well.
mhm.
So I'd say Dijkstra is pretty fair, topological sort's pretty fair. Plus, I don't think those are the hardest things. Like if you just do
Mhm.
the algorithm like 5 or 10 times, spend a
Yes, you're
day,
right. They are
you'll
not
like
difficult at
they're
all.
not difficult. So
It's
people
just
are
self.
afraid of like I'd rather get asked that than some super hard sliding window thing that's like,
I
whatever.
know,
Like
right?
so
Like those are like so difficult to get through
yeah,
because your
it's
mind
so
has to be like the
yeah.
calmest doing
Yeah,
that.
so people think that like DP or whatever is hard. It's like there's plenty of super hard problems that just use like a two pointer, but it's just
I,
like super not obvious what to do. So yeah. So
I had
I would
sliding
honestly
into
think
Thomas.
Dijkstra's is like free points because like usually
Mhm,
when they ask Dijkstra's, it's
mhm.
just really straightforward
Yes,
Dijkstra's, and you
yes,
just like, do you know it, code it, done. Same thing with DP. They usually don't ask hard DP questions, so it's like, do you know basic DP? Okay, done. Like, you know.
yeah. No, I would say a, a hard graph problem is much easier than like this problem. It's a medium. I would say it's a medium.
Hmm.
Is much easier than even a easy medium greedy problem. Like those are like I feel the worst.
Yeah, because the greedy ones you have to. There's a lot of like intuition you need. You need to
Yes,
figure
if
out that it's
you have not
greedy and
seen it,
stuff.
it's like
Yeah.
bound to like run into trouble.
Yes. Now I will say that,
Mm,
and I thought this before, I was like, how do people solve all these hard problems? Do you just have to have
mm,
seen it before? It's like when you've actually done enough, like I've done like 1700, when you've done enough, you do get a ton of algorithmic like like you get problems you haven't seen and you can figure it out because you get a lot better at that. So
okay.
yeah, when you first start doing hards and like harder
Mm,
mediums, you're like, man, if I haven't seen it, like how do I do it? But it's totally possible to solve them without having seen them, once you've done enough. But
okay.
it's hard to do that many. So that's the main thing I would say is like
Mm,
your. So I wouldn't really give you a grade here because I just feel like you were quite unfamiliar with like the algorithm. So I would just say try again.
mm,
You have stuff coming up. Try again in like a month or so once your
mm,
coding is like good. And I
mm,
definitely think you can like because the problem solving I feel like is the hardest part. Like knowing the algorithms. If you know that, then the
mm,
coding part you can kind of work on and get that like up to speed pretty quickly. If you can't go from problem to algorithm in
mm.
like a reasonable amount of time, that part takes a while to improve. So I feel like that part you're good in. The part you need to really work on is like coding and familiarity with like algorithms and coding them quickly.
Okay,
Yeah. Okay,
okay.
so what was the thing? You can ask me now if you wanted to talk about some other stuff. Happy to do that.